So yesterday we talked about ARoCs, right? Average rates of change. Okay? And we used the difference quotient. Okay? So we said that the average rate of change over the interval A to B was f of B minus f of A all over B minus A. Yes? And then we went on and we talked about IRoCs. And we said, well, so that's our average rate of change. Our instantaneous rate of change, we went from, what did we say? We went from a number to, and then to t, right? I think is what we said yesterday. So we went from a number to t. And we said that that then was the limit as t approached the number of f of t minus f of the number all over t minus that number. Okay, we did all that yesterday. But it became kind of a pain, right? Because we, for every instantaneous velocity that we had to do, we had to recalculate. Okay? So today what we're going to do is we're going to find the IRoC function. Okay? So we're going to take the instantaneous rate of change and we're going to find a function for it, and then we can use that function and we can find our instantaneous velocity at any point in time. Okay? So the function that we have is example 5. It is in your white packet. Okay? It is negative 3t squared plus 5t is the function. Okay? So we want to find the IRoC. Well, now instead of finding the IRoC at a specific number, now what I'm going to do is now I'm going to find the IRoC at t, and I'm going to have my interval go to t plus h. Okay? So that I can put any time that I want in there. Okay? And what that's going to be is, now we're going to have the limit as h approaches 0. Because we want h to go to 0, so then we have that instantaneous, that interval from t to t. Okay? Which then that's going to force us to divide by 0, which is where we're going to need to do some math and some algebra. Okay? So now then this is going to become f of t plus h minus f of t all over t plus h minus t. Well, we can do that one in our head, can't we? T plus h minus t. What's that always going to be? That's just going to be h. Okay? I apologize for the construction that's going on right below us. Okay? I'm sure it's frustrating for you, but it's really frustrating for us because it just never stops. Okay? So, let's first look at finding what f of t plus h is. Well, that's going to be negative 3 times t plus h quantity squared plus 5 times t plus h. Because I'm going to put in t plus h in for t. Okay. So far, so good. So then that's going to be t squared plus 2th plus h squared So that's going to be negative 3t squared minus 6th minus 3h squared plus 5t. Oops, I almost put plus h. It's plus 5h. Agree? With that math? Okay. So that, ladies and gentlemen, is just that one right there. Okay. So this is going to be the limit, still as h goes to 0, of negative 3t squared minus 6th minus 3h squared plus 5t plus 5h. Then we've got to do this minus f of t there. So then that's going to be minus negative 3t squared plus 5t. And you told me that that was all over h. Right? Well, truthfully, this here is plus 3t squared, and this here is minus 5t. Do you agree with that? Okay. Now, well, what do we got here? Oh, well, I've got a negative 3t squared there. I got a positive 3t squared there. What happens to those two? They cancel each other out. So that one's gone, and that one's gone. I've got a positive 5t there, and I've got a negative 5t there. What happens to those two? Those cancel each other out too. So now I've got this whittled down to be the limit as h approaches 0 of negative 6th minus 3h squared plus 5h all over h. Can I send h to 0 yet? Nope, because I'm still dividing by 0 then, right? But what can I do to the top? I can factor out an h. So then this would become agree with that. And then what can I do now? What about my h's? We can get rid of them. Okay. Can I now send h to 0? Yeah, because now I don't have to worry about dividing by 0 because I don't have a fraction anymore. So if I send h to 0, what about this term right here? Does anything change with negative 6t? Nope. So that's going to stay negative 6t. What about negative 3h? It becomes 0, right? So I can forget about it. What about 5? Just stays 5, right? We call this the first derivative of the function. Okay? So it's f prime of t. Sorry. Okay? So we call that f prime of t, and that is the IRoC function. So if I wanted to figure out the instantaneous velocity at 2, I would plug 2 into that function and get my instantaneous velocity at t equals 2. Well, 2 times -6 is -12, plus 5 is -7. So the IRoC at that's a bad at. So the IRoC at 2 seconds is -7 meters per second. Okay. What's the IRoC at half of a second? What do we got? 2? Okay. At 78 seconds. It's a big number, but we could figure it out, right? -6 times 78 plus 5, -463 meters per second. Okay? All right? So we don't have to keep redoing those calculations. We can do them once, and then we've got them all the way through as long as our function doesn't change. Okay? Now, when your function changes, then you got to do it again. Okay? The cool thing is so the function, because this is going to come up in the next problem, the function is going to be our position. Okay? It's how far away you are from the starting point. That's what your function tells you. Your first derivative is going to tell you your velocity at any time. Okay?
When you say first derivative,
that's this. I said that we just found the first derivative.
Yes. Why are you saying first?
Because there's a second derivative.
Is like a second derivative to describe the same equation?
Yep.
Oh.
Yep. Well, so then you would run, for the second derivative, you would run all of this on this function now. You know what I mean? So you would find the limit as h goes to 0 of f prime of t plus h minus f prime of t all over h. You know what I mean? You do the exact same process again, because that would then give you acceleration.
Yeah.
Okay? Right? So you can so the first derivative gives you velocity, second derivative gives you acceleration. We're not going to get into acceleration. We're saving that for Krug's next year. Yeah. Mm-hmm. Okay? Okay? So, let's do example number 6, or I want you to do example number 6 now. Okay? So a new function, 30t minus 5t squared, and answer me those 3 questions. I think those are your only 3 questions for example 6. Yep. You don't have to scroll down. Okay? Answer me those 3 questions for example 6. Agree that the object is 40 meters away from its starting point after 2 seconds. Yes? Okay. Oh, let's see, what do we got here? So that's going to be 120 minus 80. 4 squared is 80 minus 30 plus 5. 40, 10, 15. I get an average rate of change of 5 meters per second. Yes? Yeah? Okay. 30t minus 5t squared. I might need to remember that one. I got it right here. All right, so my IRoC then. Yes? So then that is going to be so we're going to have 30 times h minus 5 times that, then minus, that, all of that over h. So we've got 30t plus 30h minus 5t squared minus 10th minus 5h squared. Then we've got minus 30t plus 5t squared. All of that still over h. This 30t gets canceled out by that negative 30t. This negative 5t squared gets canceled out by that positive 5t squared. So that leaves me with 30h minus 10th minus 5h squared all over h. Can they all be divided by h? Yep. So then that's going to be the limit as h approaches 0 of 30 minus 10t minus 5h. If I send h to 0, I get the IRoC function, or the derivative as 30 minus 10t. And then if I have to, I can calculate at t equals 0. So when it starts, the function or the object is moving at 30 meters per second. At t equals 1, it's moving at 20 meters per second. At t equal 2, it's moving at 10 meters per second. What do we know about this object? But what? How is it changing? It's getting slower. It's slowing down. It's decelerating, right? Yeah. At t equals 3, what happens? Hey, what? It stops because the velocity is 0. So it stops. At t equals 4, the velocity is negative, right? Negative 10. So which direction is, so at the start, it's moving out away from the starting object, right? After 3 seconds, it does what? Stops, and then what? Starts coming backwards, starts coming back towards the start, okay? And then it's going to continue on going in that backward or in that reverse direction. Okay? You have enough information now to do worksheet letter B. You do have enough information to do worksheet letter C too, but Schmeling didn't hand it out, so I'm not going to hand it out to you guys either.